Okay, so these notes are over solving linear systems algebraically. We're going to start off with solving by substitution. So I have the system negative 2x plus y equals 8 and 3x plus y equals negative 2. So what I can do if solving by substitution is I can take one of my equations and solve for one of my variables and then plug that variable into the other equation. So I have negative 2x plus y equals 8, so I can add 2x to each side so that I have y equals 2x plus 8. And now I can take that 2x plus 8 and plug it in for x in the other equation. So I have 3x plus, instead of y, I'm plugging in 2x plus 8 equals negative 2. If I had anything to distribute in front of my parentheses, I would do that now, but I don't have anything to distribute. So now I'm going to combine like terms. So 3x plus 2x is 5x plus 8 equals negative 2. And now we're going to start to solve for x, so I'm going to subtract 8 from each side. So I get that 5x equals negative 10, and then I'm going to divide both sides by 5. So I get that x equals negative 2. Well, then with that information, I can take what x equals, and I can plug it into one of my equations and solve for x. So here, I'm using the top equation whenever I had y equals 2x plus 8. So I'm going to plug in negative 2 for x. So I'm going to do 2 times negative 2 plus 8, which would give me negative 4 plus 8, which would give me that y equals 4. So my solution is the point negative 2, 4. So you solve for one of your variables in one of your equations, plug that into the other equation, solve for that variable, and then plug that solution into one of the equations to solve for your second variable. So here I have 5x minus 3y equals 2 and x plus 2y equals 3. So I want to get one of my variables alone in one of my equations. And the easiest variable to get all alone is the x in the second equation. So I'm going to subtract 2y from each side. So I get that x equals negative 2y plus 3. And now I'm going to take this negative 2y plus 3, that's equal to x, and I'm going to plug it into my first equation for x. So instead of having 5x, I'm going to have 5 times negative 2y plus 3 minus 3y equals 2. So all I did was replace the x with negative 2y plus 3. My next step is I need to distribute. So my 5 needs to go to the negative 2y and to the 3. So I get negative 10y plus 15 minus 3y equals 2. I'm going to combine like terms, so I get negative 13y plus 15 equals 2. And I'm going to subtract 15, so I get negative 13y equals negative 13. Divide both sides by negative 13, so I get that y equals 1. Well, now I can take what y equals, which is 1, and plug it into one of my equations and solve for x now. So now I'm going to do x equals negative 2 times 1 plus 3. So x equals negative 2 plus 3, which is positive 1. So my solution is 1, 1. X always comes first. So my solution is 1, 1. My second example, I have negative 4x plus y equals 0 and 2x minus 3y equals 10. So my variable that's going to be the easiest to solve for is going to be y. I can get y alone in the top equation really easy by just adding 4x. So in the top equation I have that y equals, I don't need the 0, so y equals 4x. So now I can take what y equals, which is 4x, and I can plug it into my other equation for y. So I now have 2x minus 3, but instead of y, I'm going to plug in 4x equals 10. And now we need to multiply this negative 3 to the 4x. So 2x minus 12x equals 10. Combine like terms. So negative 10x equals 10. Divide by negative 10. So I get that x equals negative 1. Well, now that I have that x equals negative 1, I can take that negative 1 and plug it in for x into one of the equations and solve for y. So y equals 4 times negative 1, which means that y equals negative 4. So my solution is negative 1, 4. Okay. All right, a couple more examples. I have negative 2x plus 7y equals 10, and x minus 3y equals negative 3. So the variable that's going to be the easiest to solve for is going to be x in the second equation. Okay, so always take a step back and look and see what's going to be the easiest method. So I'm going to just add 3y to each side. So in my second equation, I get that x equals 3y minus 3. So now I can take what x equals in the second equation, and I can plug it in for x in my first equation. So I have negative 2, but instead of having x, I'm going to plug in 3y minus 3. Then we have plus 7y equals 10. I need to distribute my negative 2. So I have negative 6y plus 6 plus 7y equals 10. I can combine like terms, so negative 6y and 7y becomes 1y plus 6 equals 10. And I can subtract 6 now, and I get that y equals 4. Now that I have what y equals, I can take that 4 and plug it in for y and solve for x now. So x equals 3 times 4 minus 3. So x equals 12 minus 3. So I get that x equals 9. So my solution is 9, 4. X always comes first. All right, my last example here is 4y minus x equals negative 24, and 3x equals 12y plus 72. All right, you can approach this one several different ways. You can solve for x in the top equation really quick and easy, or you can do the bottom equation and divide everything in the bottom equation by 3, which that's what I'm going to do. Since I already have 3x, I'm just going to divide by 3 and get x alone. So when I do that, I get that x equals 4y, let's see here, 72 divided by 3 gives me 24. So 4y plus 24. And now that I have that x equals 4y plus 24, I'm going to take that and I'm going to plug it into my top equation for x. So I get 4y minus, I'm going to plug in 4y plus 24 in parentheses. And the reason why I'm putting that in parentheses is because this negative has to distribute to both terms. So now I have 4y minus 4y minus 24 equals negative 24, which means I get 0y minus 24 equals negative 24. And when I add 24, I get that 0y equals 0. Okay, that is not an error there. I get that 0 equals 0. That tells me something is up with these two equations. So I have that x equals 4y plus 24. I'm going to go ahead and look at my top equation and see what happens if I would have solved for x. There's a possibility these are the exact same line. So if I subtract 4y in the top, I have negative x equals negative 4y minus 24. And then if I divide by negative 1, I get that x equals 4y plus 24, which is the exact same thing I got here. So these are the exact same line, which means this is an infinite number of solutions. And I have run out of space to write this. It's an infinite number of solutions. So when 0 equals 0, something's up, that's an infinite number of solutions because they're the exact same line. Had these lines been parallel lines, that would have been a no solution because parallel lines never cross each other. And that is it for solving systems by substitution.